Hi, Assalamualaikum. Today I'm going to present to you about our title assignment, which is friction stir welding process. I'm going to introduce myself. My name is Said Noraminuddin, and this is my fellow groupmate, which is Ahmed Daniel, Muhammad Nakyuddin, and Nurul Aisha. In this presentation, we divided into four sections, which are introduction, review, application, and summary. So here I'm going to present about abstract and introduction. Friction stir welding is a solid-state joining technique that uses a non-consumable tool to join two facing workpieces without melting the workpiece material. Heat created by friction between the rotating tool and the workpiece material causes a softened region nearby the FSW tool. It is primarily utilized on extruded aluminum, especially for structures that require extremely strong weld. Aluminum alloys, copper alloys, titanium alloys, mild steel, stainless steel, and magnesium alloys can be joined using FSW. FSW has recently succeeded, joining dissimilar metals such as aluminum and magnesium alloys. FSW is used in contemporary shipbuilding, train design, and aerospace applications. For introduction, in late 1991, TWI had an original and potentially revolutionary welding idea. The process was appropriately referred to as friction stir welding. In December of the year, TWI submitted an application for an international patent. In FSW, a non-consumable tool is rotated and inserted into the seam between two workpieces. After that, the tool is forced through the interface, heating and softening the material due to friction. The softened material is then mechanically combined by the rotating instrument to create a solid-state bond.
Okay, and now I'll continue on the working principle. The working principle for friction stir welding is to set up two metal components to be linked are aligned and securely secure in place. A specialist tool known as friction stir welding tool is employed. This tool is made up of a cylindrical shoulder and a tempered threaded pin. The shoulder exerts downwards force and produces heat, which the pin causes friction and stirs the metal. And now for the process parameters: tools position, spindle RPM traverse speed, tilt angle, joint design, and joint preparation. For the joint design, we have six types of design, which is butt joint, lap joint, tube to sheet joint, T-joint, corner joint, and lastly, double corner joint.
I will continue with application of friction stir welding. FS welding is widely used in many industries to join various metal parts. Due to its advantage, friction stir welding in use in the following industries. First, aerospace industry, automotive, shipbuilding, rail industry, energy sector, defense and military application, construction industry, and general manufacturing. So this is effect of parameter involved. The first is two rotation speed. The rotation speed of the FS welding tool effect the amount of frictional heat generated and the material flow during welding. Higher rotation speed result in more heat generation, which can increase the plasticity of the material and facilitate better mixing. Second is tool design. Different tool design are used depending on the application and the material being welded. Optimized tool design can result in improved heat transfer, better material mixing, and enhanced joint strength. Third is material properties. Different material require specific parameter adjustment to achieve optimal weld quality. And last is axial force. The axial force applied to the FS welding tool effect the penetration depth and material flow. Higher axial force increase the penetration depth, leading to better consolidation and stronger weld.
Lastly is a summary. First for performance. An organized tools goes into material during the frictions, the welding FSW process, causing friction between the tool and the metal that cause center heat when the tool advances along a path over its surface. The material heats up and softens when the tool is then passed through the interface. So second is advantage of FSW. There are five mainly advantages, which is first, strong and high quality joints. Second, environmentally friendly. Third, compatibility of material. Four, increased fatigue resistance. And lastly, improved efficiency. While friction stability, FSW has many advantages, they are also have certain limitations. First is limited joint configuration. For creating butt joints and lap joints, FSW is the best choice. But for the complex joints, such as corner joints or joints with large chest in thickness or shape, they are not as well suited for it. Secondly is for material thickness. This is often preferred for welding material that range in thickness from 2 to 25 millimeter. This is a quite thin or these thick materials may make it difficult to get the best joint strength and welding quality. Thirdly is equipment limitation. Fourthly is limited joint access. This is particularly in tight or difficult to reach in the setting of FSW. This is might face challenge while to trying to gain entry to certain regions for welding. So, fourth is process control and skill requirement, and lastly is material compatibility. Some materials might not be acceptable for this welding because of the difficult with material that have low melting points or are at risk of change at higher temperatures. So that's all for our group. Thank you.